Hi everyone. Today we're gonna talk about different methods to calculate concentration of solutions. What is a concentration of solution? Concentration is a ratio of solute in a solution to either solvent or total solution. So in all of the concentration calculations of solutions, we will have a solute and is going to be on top, and then we have a solvent or total solution in the denominator or bottom of the equation. What is a solvent, guys? And what is a solute? Solute and solvent together make a solution, which is we were calling before homogeneous mixture. Solute is dissolved in the solvent like NaCl or table salt when it's dissolved in the water. So a table salt will be solute and usually is a smaller amount, and the solvent is the water, which is always the more amount. So there are three common ways to express concentration. One is molarity, one is percent concentration, and one is molality. So let's start with molarity. Molarity, which you can see that's or is identified as M capital. Also, the unit of it is showed by M capital. Is basically mole of solute over liter of solution. So what do you need to answer a molarity question? You need to have a mole of solution, mole of solute, for example, table salt, over the liter of the solution, which is basically a combination of solute and solvent. Always pay attention that the formularity of the solution, we always should have a liter of solution in the denominator. So for example, we have a 250 milliliter of solution contain this much of mole of NaCl. It says calculate the molarity of the solution. So what's the molarity? Is already asked for molarity. So what it should come with our mind should be mole of solute over the liter of solution. So we're gonna put the mole on top and the liter of solution. So it was a milliliter. What should I do to convert to liter? Divide by 1000. So make sure you keep the the number of significant figures, but it will be converted to liter. At the end, we have a 0.536 mole per liter, which is a unit of molarity or M capital. Know that the molarity is a mole of solute per liter of solution. So I already have a milliliter. Should I put it here? I should first convert it to the liter, divide by 1000, then I put it here. So should I put this 7.83 gram of NaCl here? No, I should first convert to mole. So first I will convert it to mole, divide by 58.44 gram, and I basically gram per mole, because we know that the unit for the molar mass is gram per mole, and you see that 0.134 mole of NaCl. Then I'm gonna put it on top and I calculate the mole of NaCl. So make sure if you see a gram, first convert to mole, and in the bottom should be always liter of solution. Okay, so for the second one, we have the percent concentrations. Percent concentration, when you hear of percent, what does it mean? Is the amount of solute in 100 part of solution. So it's basically is like other percentages. We want the part over total times 100. There are three ways to express percent concentration. Let's go by each of them. One of them is weight or mass percent. You can see it this way. And then you see that here, how you calculate that? You should have a solute mass over solution mass. So here you will not convert to mole. Again, here you will not convert to mole. They give you a mass, solute mass, and they give you the solution mass. Okay, so you do not need to convert to mole. The important thing, you should make sure that the both units of mass should be in the same unit. If it's in the gram, should be both in gram. If it's in the kilogram, it should both be in the kilogram. The second one is weight over volume percent, or W over V. The unit is always gram per milliliter. Again, we will not convert to mole here. Gram of solute over the milliliter of solution times 100. Volume over volume percent, or VV percent. Again, both should be the same unit. So solute volume over solution volume times 100. You might ask, okay, how I know which one, which of these I should use in the question? Is kind of simple, guys. If in the question they give you solute mass and solution mass, you use weight over weight. So they give you 2 grams or 2 kilograms, for example, you should use the first one. If they give you 1 weight and 1 mass and 1 volume, you should use this one. If they give you 2 volume, you should use the third one. Okay, so let's do the first one. Calculate the weight percent of the solution by dissolving 15 gram of hydrocortisone in 15 gram of solution. How we can do that? Solute mass over the solution mass time 100, because they both are gram. The first thing, and they ask for the mass over mass. That's the first thing it's gonna come to my mind. The both of these given ones are, the given numbers are in gram. So I will put a solute divide by the solution. So if you don't know which one, even if they don't give you a solution here, always the one number with the higher number is a solution basically, and you multiply by 100, that would be 13.0%. Okay guys, let's do another type of questions which can be given in the mass over mass percent. We just abbreviated to mass percent. Mass percent equals to mass of solute over mass of solute plus mass of solvent. What does it mean? I just separated the components of solution to the solute plus solvent. If you remember, when we make an HCl solution or table salt solution, I added table salt to the water, right? To make an HCl or table salt solution. So we just separated the component of the solution. So let's see how they can give the question. Calculate the weight over weight percent of a solution prepared by dissolving 15 gram of hydrocortisone in 100 gram of water. You might say, okay, they don't give me the solution here. They give me water here. That's a solvent. So what I should do, I should divide my solute, which is 15 gram and is a smaller amount on top, and add up my solute plus my solvent. 100 plus 15. What's come out? Add up 100 plus 15 is 150 time 100. You might ask, okay, how I know what are the solvents and how I know? So for sure, water is a solvent, right? So know that water is solvent. Okay, so they give you a hint, guys. For example, they tell you a solvent or they give you water. So you will figure out, and as you do more practice, you will understand how to solve it, right? Okay, so let's go to another percent concentration, weight over volume. So weight over volume is gram of solute over the milliliter of solution time 100. So let's do a question of it. Calculate weight over volume percent of a solution prepared by dissolving 8.95 gram of hydrocortisone in enough water to give 50 milliliter of solution. So here I have the solute 8.95 gram. How I know this is my solute? Because it's less amount, right? The less amount is always a solute. Divide by my solution, 50 milliliter of solution. And I'm gonna put it here. Another type of question I just tell it is that they might give you both, like here, like in the volume, like in the here instead of the 8.95 gram, they give you 8.95 milliliter and ask for W over V percent. Do you think how I can solve it? If they gave me here milliliter here and also milliliter here. No, it is not a right question, guys. So they give you enough information. What do you think they should give me? They should give me a density here. So they give me a density. I will convert my milliliter here that they gave me, like in the question I said, I convert it to the gram and then I solve this question. So if they gave you milliliter and ask for the volume over V percent, they should give you a density basically to convert it to the milliliter. Okay, let's go to a last one. A solution is made by dissolving 250 milliliter of hydrocortisone in enough water to give 1.50 liter of solution. Calculate this. So I know that when they ask about this, that's the solute volume over the solution volume times 100. So the important thing you should pay attention is that, guys, that you should make sure it's the same unit. So I convert either of them, doesn't matter, to make sure the same unit. Here I decide to convert 250 milliliter to liter. I divide it by 1000 and multiply 100. Make sure, guys, follow the sig-fig rule in all of the steps of these calculations. Okay, let's go to the last one in the basically solution concentrations, which is molality. Molality is different from molarity. So make sure that make a difference. I would recommend you, as I always say, make a flashcard to kind of put it in your mind. So mole of solute is molality, is mole of solute over the kilogram of solvent. There are also some mnemonics you can kind of basically memorize it. Molality is a king, basically, since it has two L's. So you can basically remember it to do that. How we can answer the questions of molality. What's the molality of a molality of a solution prepared by dissolving this much mole of starch in 0.50 kilogram of water? You see, there is a water here, which is solvent. Make sure molality, in the molality, you should have a solvent, kilogram of solvent in the denominator. So it's so much different from molarity, okay? So how we do that? Molality is basically italic M, small m in italic form. So we should make sure we should have a mole on top. I already have a mole. They made it easy for us here, but they can give you a gram in the question. What should you do? You should convert to mole first and then put it here. So we're gonna put the mole here and divide by the kilogram of water. So you're gonna put the solvent here, and that would be 0.20. The unit is M in italic, molal. We call it molal, 0.20 molal. Make sure follow the Sigfig rule here. So these are the abbreviation of what I talked about, the different ways to calculate the solution concentrations. And just to tell you that molality is different from molarity because it's colligative property. Okay, so let's see how to calculate ion concentration. How, for example, let's go here. They gave us 1 molar of CaCl2, and they asked to calculate the molarity of each ion in the solution of calcium chloride. So they gave me 1.0 molar of these, and they asked me to calculate the molarity of each of these, or concentration of each of these ions. So what you're gonna do is that the reported concentration of a solution containing of an ionic compound, which here I have an ionic compound, right, is metal and non-metal, so it's ionic compound, reflects the concentration of the solute before it is dissolved. So whatever is the concentration of the solute before dissolving the solution is going to be a concentration of it. So let's do this one. So I have 1.0 molar of CaCl2 solution. So I just give you a simple calculations. Look at the subscript of each of the ions, guys. They always give you guys the concentration of solution, like here you see. To find each of the concentrations, you will look at the subscript. If the subscript is 1, the concentration of ion will be the same as what is given for the compound, which is 1 molar. So the concentration of calcium is 1 molar or 1 mole of calcium 2 plus per liter. For what about chlorine, guys? What do you think will be chlorine? We should multiply the 2 by our molarity of a solution. So it's going to be 2 times 1.0. So the molarity of Cl or chlorine will be 2 mole of chlorine per liter. Okay, so let's do an example. Determine the molarity of or molar concentration of each ions in this compound. And they gave me the molarity. So what should I do? I should look at the subscript. So sodium is 3, right? So I multiply this 1.5 times 3. This is going to be molarity of Na plus. What about phosphate, guys? This is polyatomic ion, right? Polyatomic ion. So this is only 1 unit of it. We do not have here any parentheses to show I have more than 1. I have only 1 polyatomic ion of phosphate here. So it would be only 1.5 molar of phosphate because it's 1 only. So 1.5 times 1 would be 1.5 molar of phosphate. Okay, solution, dilution or dilution calculations. In dilution calculations, we have basically one side of the basically we have M1V1 equals to M2V2. What does it mean? Do you remember, guys, the gas calculations when I was, for example, Boyle's law? Do you remember that? It was P1V1 equals to P2V2. So I had one phase of the gas or one stage of the gas in one side and the second stage of the gas in the second or the right side of it. So it's almost the same, guys, here. In one side, we have a stock solution or concentrated solution. And in the other side, I have a diluted solution of the same compound. What is concentrated solution? For example, you buy a very concentrated orange juice from Walmart and you want to make orange juice for your child. It's very sugary, right? Because it's so sugary. So what you're gonna do, you're gonna add some water to it, right? To be able to be less sugary and to be drinkable. So this is basically what's happening. In the left side, it doesn't matter, to be honest, what side is concentrated. I just choose here the left side. For example, the left side here would be the concentrated or more sugary orange juice, and the right side will be my less sugary orange juice. So what is M here? M is molarity, M capital. If you remember, we learned that is molarity. V is volume. M also again is molarity and V is volume. So as you see here, M1 and V1 are the molarity and volume of the initial concentrated solution, and M2, V2 are the molarity and volume of the final diluted solution. So as you remember from the Boyle's law, they provide us 3 known numbers and they ask for 1 unknown number. So it's almost the same way, guys, that you were doing the Boyle's law. But here we have molarity and volume. Okay, so let's do a question on it. So first, make sure that you abbreviate. That's really helpful. It says prepare 5 liters of a 1.5 molar KCl solution from a 12 molar stock solution. When you see a stock solution, guys, it means a concentrated solution. Just right next to it always, a stock solution is the concentrated. So here they just made it easy for us. They just told that a stock solution. So what we're gonna do? So we're gonna just say, okay, I know that the concentrated solution is 12. So I put M1 and then I do not have the basically V1 here. So I'm going to basically find the V1 here, but I have the M2. My M2 here, 1.50 molar, and my V2 here is 5 liter. So they gave me 3 known and they asked for 1 unknown. So which is V1 here. What should I do, guys? M1 V1 equal to M2 V2. So I'm gonna solve for M1, so I'm gonna solve for V1, and I come with 0.625 liter. So I need 0.625 liter of KCl, and how much do you think water I should add to make diluted 5 liter solution? Because I should make this solution, right? 5 liter. Imagine you have a concentrated 12 molar of KCl, right? It's concentrated. You put it in the bottom of beaker. So we calculated it 0.625 liter of a stock solution, which is 12 molar. So I add 0.625 liter of 12 molar in the bottom of beaker. How much do you think I should add water to make 5 liter of less concentrated, which is 1.5 molar? I should subtract it minus 5 liter minus my concentrated liter from the concentrated solution. This is going to be amount that should be added to make the 5 liter of 1.5 molar KCl. This is called, guys, dilution solution. What about they don't give me, if they don't give me a stock solution? How do you think, guys, I know which one is concentrated, more concentrated? If they don't give me here a stock solution, they just tell me 12.0 molar of solution. Because it's higher number, higher molarity, okay? Higher molarity always means concentrated solution. The higher the molarity is, the higher the concentration. So write it down somewhere. The higher the molarity is, the higher the concentration. So this is my concentrated or stock solution. And the smaller number is a less concentrated solution. Okay. Let's go to another important way to do the calculations. So this equation basically works whenever they give me, for example, in this type of questions, they give me 2 known and they ask for one unknown always. Let's do this question. If the volume of this molar of NaCl is 0.25 liter, find the mole of the compound. You should always pay attention, guys, that always for N equals to mV, M is molarity and V is the liter of solution. V is the liter of solution. V is what? Is liter. The unit of V is liter. In N equals to mV. Is basically, what is remind you guys mV here? Is remind me of M1 V1 equal to M2 V2. So mV equals to N, right? So we basically equal N1 to N2. We equal mole of one side to mole of another side of the solution. You know what I mean, guys? So N equal to mV. So, but make sure in N equals to mV, we should put a liter of solution always. So I have a liter of solution, I'm lucky, but always pay attention. I multiply by molarity and I find the mole of NaCl. What about here, guys? They ask for the gram of the compound here instead of the mole. Then at the end, I should use the molecular weight of NaCl and convert this mole to gram of NaCl. Let me, before go on, I talk about a more thing about these dilution questions. In dilution questions, if you remember, if we have the both sides here, like Boyle's law, if you remember the Boyle's law, we should be the same unit always. Okay, it should be the same unit. So make sure both sides should be the same unit. So if the left side is molarity, the right side should be molarity. If the left side is in liter, the right side should be in the liter. So make sure both sides should be in the same unit. Okay, it's very important. But in the N equal to MV, we always have a V in a liter and M in molarity.